Hi guys, let's try one more problem. The following figure gives displacement versus time plot of a particle executing one-dimensional simple harmonic motion. You will learn about this motion in detail in chapter 14. Gives the sign of position, velocity and acceleration variables of the particles at t equal to 0.3 second, 1.2 second and minus 1.2 second. So from the graph, if I take at different locations, when t time equal to 1.3 second, suppose if I take at 1.3 at here in the graph, so this is 0.3 second. At 0.3 second, what is the sign of position and what is the sign? Means we need to say whether it is positive or negative. And sign of velocity and acceleration. So these details we need to fill at 0.3 seconds, and similarly at given that I think 1.2 second and third one negative 1.2 second. So if it is 1.2, if I draw one more line at here, so 1.2, so let me take this as 1.2 at here, and negative 1.2, so 1.2, so maybe here somewhere, so this is minus 1.2 seconds. So this is not the motion is straight line, so this is simple harmonic motion. In short form we call that SHM, simple harmonic motion. So this is also one-dimensional motion. Let us say simple harmonic motion, how it works first. So this is the setup of simple harmonic motion. Simple harmonic contains, to make simple harmonic motion contains, we need a simple pendulum. So this is pendulum setup. It's having mass, and that mass is tie up with a string. Now if I take at here a straight line, suppose this is a straight line, if I make a straight line across there, since we were dealing with motion along a, so let me draw a straight line. Yeah, let it be straight line. Now if I take in the straight line, one is positive x-axis, so this is positive and this is negative. And if I take this mass at here, and the mass starts to move back and forth, so this we define as SHM. Now at this highest point, if I take the position a number, so here it is minus, at here that is minus 3 centimeter, and if I take that in another side, suppose if I take this at here at this highest point, so this is also plus 3 centimeter. Now if I can hit play button, so this mass is swinging back and forth between minus 3 centimeter to plus 3 centimeter. It is not going above that and it is not going below that. So if I can take time, so time is running at here, if you can see. So time is running for 1 second, 2 second, 3 second, like that. Now if I wish, I would like to plot a graph of position versus time. So the time is at here and this is position. Now in the position, it's always going negative 3 centimeters to positive 3 centimeter. So if I draw a plot, first positive 3 centimeter, then negative 3, then positive and negative, and it will be go like this. So similarly, so it will be go on other side also. So this is across plus 3 and this is across minus 3. So that's why this simple harmonic motion graph is a representation of sine curve. So this shape we call as sine, the mathematical trigonometric sine function. The same it looks like. Now this is the same what the problem which is given for us. Now, so here we understood that the position is always changing from negative 3 centimeters to positive 3 centimeters. So it will be present. Even though how long the time takes, the position always swings back and forth between negative 3 centimeters to positive 3 centimeters. Now that's about position. What about, we need to know that velocity and acceleration. Suppose here I am having an option right now. If we can make this swing, here we can see two arrow marks. So these two arrow marks are representing, the yellow arrow mark is representing acceleration and green is representing velocity. Therefore green is velocity and yellow is acceleration. Not only that, here we already know the position. So position is minus x2 plus x. Now if it is made to move, if you can observe, at each time the velocity and acceleration direction gets changes. Now at this highest point, on this negative side, highest point, the velocity of that pendulum is obviously 0. So that's the reason the pendulum is do not move up to here. So the pendulum is do not come up to here. Why? Because its velocity at here becomes 0. But here you can see velocity direction. This is the velocity direction and this is the acceleration direction. At this highest point, velocity is minimum 0 and acceleration is maximum, and they both are in opposite direction. So the same thing happens at another end also. So when it comes to another end, so the bob velocity at the another end, right now at here, if you can take that, yeah, here again the velocity value goes to 0. So here velocity equal to 0 and acceleration equal to maximum. So that's the reason the bob do not come up to at here. Now for every moment in this situation, for every moment the velocity and accelerations, they will be changed. Now at the center you can see velocity is representing in this direction. So this is velocity of the mass bob and acceleration is upward direction. So this is the speciality of the simple harmonic motion, SHM. So this motion we will study in detail in last chapter, but here we got the preliminary knowledge about the directions of velocity, acceleration and displacement. Let us try to find in the given problem what are the corresponding signs. Now it comes to 0.3 seconds. At the 0.3 seconds, if you see this displacement, the position is positive or negative. So here the position is negative. So it is represent that the position at here is negative. So the position is representing in the negative x-axis direction. If it is a positive, so obviously it comes to negative x-axis. So the position at 0.3 goes to negative. So x less than 0. So if the position is negative, what about the x velocity? So we know the velocity equal to the rate of change of displacement dx by dt. If displacement is negative, what about the velocity? If x is negative, so velocity is also negative. So here velocity is also negative. The sign of velocity is x less than 0, means negative. And coming to acceleration. For the acceleration, I will give a formula relation in the SHM. Acceleration in SHM is directly proportional to displacement. And we will write that acceleration A equal to minus omega square x. Here omega is known as proportionality constant. We are taking that omega as proportionality constant. So to find the acceleration, I will use this formula. So acceleration A equal to minus omega square x. Now to find the acceleration, you can substitute here x is negative, A equal to minus of omega square of minus x, and this total value will becomes positive. It means omega square x. Therefore, I got it here acceleration A equal to positive omega square x. Now I can write it here acceleration x is positive, that is x greater than 0. To represent the sign, I am using symbol set here, you follow that. So it is positive. So at 0.3 seconds, the position is positive and velocity is positive and acceleration is, position is negative, velocity is negative and acceleration is positive. So like that we have to find it out in the rest of the places also. Now coming to the next, at 1.2 seconds positive. Let me clear so it can be do easily. Now coming to at 1.2 seconds. So this is the situation 1.2 seconds. Now in these situations, what about position? The position at here equal to x equal to positive. Now we can mention that position at 1.2 seconds x greater than 0. It means positive. What about velocity? Velocity equal to dx by dt. So if x is positive and velocity is also positive, so in this case x greater than 0, which is positive. What about acceleration? Acceleration A equal to minus omega square x. So therefore if x is positive, therefore acceleration A equal to minus omega square of plus x. So we can get acceleration equal to minus omega square x. It means acceleration is negative. So acceleration is less than 0, which is negative. Oops, here I should mention as velocity. So here also I should mention that as velocity. Now coming at 1.2 second. So at 1.2 second at here. So now draw the position first. So then it's easy to understand. Now the position at here, if I take a line, so here the position, so x equal to negative, so that is minus 1 point, sorry, that is minus, x is negative, x is negative, that is x is less than 0. But what about velocity? Velocity equal to dx by dt, rate of change of displacement. Since x is negative and here time is also negative, be careful, here time is given that negative 1.2. So the velocity in this particular case at 1.2, at 1.2 second, negative 1.2 seconds, which I am calculating right now, x is negative and the velocity, since position is negative and time is also negative, so now the velocity is positive, greater than 0. And what about the acceleration? Acceleration a equal to minus omega square x. So acceleration a equal to minus omega square of position is negative minus x, acceleration will becomes plus omega square x, which is positive, greater than 0. So at time t equal to minus 1.2 second, the position displacement x is negative. So the position displacement x is less than 0, which is negative, and velocity, here velocity became positive because displacement is negative and time also negative right at there. And acceleration is becomes also positive, which is greater than 0. So this is what they ask in the SHM, the signs of position, velocity, acceleration at different timings. So we will learn much more about simple harmonic motion in the last chapter.